What if I told you that every major canyon on Earth, from the Grand Canyon in Arizona to the Fish River Canyon in Namibia, shares the exact same structural characteristics? Flat floors, perfectly straight walls, consistent depths. And what if the explanation you learned in school, millions of years of slow, gradual erosion, was completely wrong? What if all these canyons were carved by the same catastrophic event, in the same way, within the same time frame? And what if the evidence has been sitting in plain sight for over a century, ignored because it contradicts everything we thought we knew about geological time? Look at any major canyon on any continent. The Grand Canyon, Valles Marineris on Mars, the Kapo Valley in Australia, the Kulka Canyon in Peru, the Yaling Tango Grand Canyon in Tibet, Kings Canyon in Australia, the Fish River Canyon in Namibia. Every single one shares identical features: vertical or near vertical walls that drop straight down for hundreds or even thousands of feet, perfectly flat canyon floors stretching for miles, consistent depths across enormous distances, and in almost every case, a relatively small river or stream trickles along the bottom, utterly inadequate to carve such massive geological structures. Traditional geology tells us these canyons formed slowly, over millions of years. Water gradually wore away rock, carving deeper and deeper channels across vast stretches of time. This theory is called uniformitarianism, the idea that the processes we see today, like erosion and deposition, have always worked at the same slow, steady rates throughout Earth's history. Charles Lyell popularized this concept in the 1830s, and it became the foundation of modern geology. But here's the problem. When you actually examine the evidence, uniformitarianism fails. It fails to explain what we see in canyons worldwide. If you're ready to question everything you thought you knew about landscapes, the first thing to understand is the Grand Canyon itself. It stretches 2,077 miles long, up to 18 miles wide, and over 1 mile deep in places. The Colorado River runs along its bottom. Conventional geology claims this tiny river carved the entire canyon over the past 5 to 6 million years, cutting down layer after layer of sedimentary rock, slowly deepening the channel while weathering and erosion widened it. This explanation has been taught for over a century. Here's the catch. The Colorado River is tiny compared to the canyon it sits in. At its deepest point, the river is only about 40 feet deep, with an average flow of around 12,000 cubic feet per second. That sounds impressive until you compare it to rivers like the Amazon or the Congo. Those massive rivers move far more water than the Colorado, yet they haven't carved canyons anywhere near the scale of the Grand Canyon. The erosion problem gets worse when you do the math. Geologists estimate that removing roughly 1,000 cubic miles of rock from the Grand Canyon would require erosion rates far higher than what the Colorado achieves today. Current studies suggest the river removes only a few millimeters of rock per 1,000 years. At that rate, carving a mile-deep canyon would take not millions, but tens or even hundreds of millions of years. Yet conventional timelines insist it happened in 5 to 6 million years. The numbers simply don't add up unless you assume erosion rates were dramatically higher in the past, an idea that directly contradicts the principle of uniformitarianism. Then there are the canyon walls themselves. Many sections of the Grand Canyon rise in sheer, vertical cliffs, with horizontal layers of sandstone, limestone, and shale clearly visible. Conventional explanations claim the Colorado River sliced through these pre-existing layers like a knife through a cake. But here's what doesn't make sense. Erosion doesn't make vertical walls. Natural river erosion produces V-shaped valleys with sloped sides. Gravity pulls rock down into the channel as water cuts downward, usually creating slopes between 30 and 45 degrees. Look at any small stream, any river valley, and you see the same pattern. The Grand Canyon is different. Its walls are vertical. In some places, they even overhang, making the canyon wider at the bottom than at the top. This is the opposite of what normal erosion produces. So, what does create vertical canyon walls and flat floors? Catastrophic flooding, massive, unstoppable flows of water, orders of magnitude larger than any river on Earth today, moving house-sized boulders hundreds of miles, carving solid rock in days or weeks instead of millions of years. The evidence for catastrophic canyon formation is not new. In 1923, a geologist named J. Harlem Brett proposed that the channeled scablands in eastern Washington state were formed not by slow erosion, but by catastrophic flooding. The scablands feature deep channels, vertical cliffs, enormous gravel deposits, and dry waterfalls carved directly into basalt bedrock. It looks like someone drained a massive lake across the landscape in a single, violent event. Brett argued that's exactly what happened. Lake Missoula, a glacial lake dammed by ice and containing more than 500 cubic miles of water, catastrophically released when the ice dam failed at the end of the last ice age. The resulting flood was the largest known freshwater flood in Earth's history, with peak discharges estimated at up to 10 times the combined flow of all rivers on Earth today. The water scoured channels hundreds of feet deep into solid basalt in just days or weeks. It created vertical cliffs, flat channel floors, dry waterfalls, and transported boulders the size of houses. The landscape it left behind looks remarkably similar to the Grand Canyon, just smaller, with direct evidence of catastrophic flooding. Initially, the geology community rejected Brett's hypothesis because it contradicted uniformitarianism. How could such an immense flood happen? Where was the evidence? Gradual erosion seemed more scientifically respectable than invoking catastrophes that sounded biblical. But Brett had the evidence. The landscape could only be explained by catastrophic water flow. By the 1960s, enough evidence had accumulated that the Missoula flood was accepted as fact. It happened. Catastrophic flooding can carve massive channels with vertical walls and flat floors in geologically instantaneous timeframes. Once you accept that principle, you have to ask, could other similar features worldwide have the same origin? The Grand Canyon itself shows signs of catastrophic water flow throughout its structure. The flat floor is not solid bedrock. It's filled with sediment deposits, characteristic of rapid deposition from massive floods. The side canyons and tributaries hang hundreds of feet above the modern river level, suggesting they were carved when water levels were far higher. Enormous boulders sit in places where the Colorado River could not possibly have moved them. The lack of talus slopes at the base of vertical cliffs further indicates rapid formation, not slow erosion over millions of years. Zooming out globally, we find the same patterns. The Fish River Canyon in Namibia is Africa's largest canyon, and the second largest in the world after the Grand Canyon. It stretches 100 miles, reaches depths of about 1,800 feet, with vertical walls and a flat floor. A small river flows along the bottom. Conventional geology claims millions of years of slow erosion created it, yet its structure mirrors the Grand Canyon perfectly. The same vertical walls, the same flat floors, the same disproportion between the small river and the massive canyon. Sediment deposits and boulder placements indicate catastrophic water flow. Australia's canyons tell the same story. Kings Canyon in the Northern Territory has vertical sandstone walls, up to 300 feet high, with a flat valley floor. The Kapati Valley stretches nearly 20 miles, with sheer cliffs and a flat base. South America hosts some of the deepest canyons on Earth. Colca Canyon in Peru reaches 13,000 feet, more than twice the depth of the Grand Canyon. Cotahuasi Canyon is even deeper. Both feature vertical walls and flat floors carved through volcanic and sedimentary layers. The rivers at the bottom are substantial, yet still nowhere near sufficient to carve these massive structures gradually. Asia's largest canyon, the Yalong Changpo Grand Canyon in Tibet, is over 17,000 feet deep, with vertical cliffs and a narrow, flat valley floor. Conventional geology attributes this to river downcutting during Himalayan uplift, but the cutting rates required defy plausibility. Catastrophic hydraulic action explains it far more simply. Even underwater canyons share these characteristics. Monterey Canyon off California, larger than the Grand Canyon, has vertical walls and a flat floor. Hudson Canyon off New York and Congo Canyon in Africa show the same features. Traditional explanations cite underwater currents over millions of years, but turbidity currents lack the power to carve vertical walls through bedrock. A more plausible scenario is massive surface water flows when sea levels were lower, scouring the channels before inundation. Here's where the story gets even more profound. The conventional geological timeline demands billions of years for Earth's features to form. Accepting uniformitarianism meant that creating massive structures like mountain ranges and canyons required immense stretches of time. This framework then influenced biology, supporting gradual evolution over hundreds of millions of years. It shaped astronomy, requiring billions of years for stars and galaxies to form. Essentially, the entire edifice of modern science rests on the assumption of slow, steady change over vast periods. But what if that assumption is wrong? What if the Earth's major geological features were formed rapidly, through catastrophic processes? The implications are staggering. Evidence for global catastrophic flooding exists on multiple fronts. Every continent has flood legends. The biblical flood is well known in Western culture, but similar stories appear in Mesopotamian, Greek, Hindu, Chinese, Native American, and Aboriginal Australian traditions. These stories describe world-covering floods that reshaped landscapes and nearly wiped out humanity. Conventional scholarship dismisses them as myths, symbolic tales of local floods exaggerated over generations. But what if these were historical memories of actual events? What if a global or near-global catastrophic flood occurred within human memory, perhaps 10 to 15,000 years ago, at the end of the last ice age? There is a plausible mechanism. About 15,000 years ago, massive ice sheets covered much of North America, Europe, and Asia. As temperatures warmed, these ice sheets began melting. But the process was not always gradual. Sudden, catastrophic releases of meltwater occurred. The Missoula floods are one confirmed example, caused by ice dam failures. Similar events likely happened worldwide. The Laurentide ice sheet over Canada and northern United States contained enough water to raise global sea levels by over 200 feet if released suddenly. Catastrophic ice sheet collapses would have unleashed floods of unimaginable scale, reshaping continents in weeks or months, not millions of years. The sedimentary layers in canyon walls support this view. They indicate rapid deposition rather than slow accumulation over millions of years. The layers are often perfectly horizontal across vast distances, with sharp boundaries between different rock types. Conventional geology interprets each layer as representing millions of years of different depositional environments, ancient seas, rivers, deltas, that came and went over eons. But lab experiments and field observations show that rapidly moving water with suspended sediments can deposit multiple distinct layers in a single event. Particles settle based on size and density as water velocity decreases. Sharp boundaries between layers indicate rapid deposition, not gradual accumulation with biological activity over thousands of years. The near absence of erosion surfaces, root traces, and burrows between layers further reinforces the case for rapid, catastrophic formation. Conventional explanations often invoke special conditions, maybe minimal biological activity, maybe exceptional preservation. But these require additional assumptions to protect existing theories, rather than accepting the simpler explanation. The layers formed rapidly during massive flood events. Occam's razor suggests the simpler solution is usually correct. Rapid deposition from catastrophic floods explains the evidence far more directly than millions of years of speculation. The economic and political implications are enormous. The oil and gas industry relies on geological dating and sedimentary basin formation over hundreds of millions of years to locate deposits. If sedimentary layers formed rapidly, our understanding of where petroleum might be found would need a complete revision. Nuclear waste disposal strategies assume geological stability over hundreds of thousands to millions of years. If Earth's geology can change catastrophically on much shorter timescales, current repositories may be fundamentally flawed. Insurance, disaster planning, infrastructure investments all rely on historical assumptions of gradual change. Catastrophic events would systematically invalidate risk models, affecting trillions of dollars worldwide. Academic institutions and museums have enormous investments in uniformitarian geology. Careers, textbooks, exhibits, research programs, all built on the assumption of slow geological processes. Accepting catastrophic geology challenges this entire foundation. Intellectual inertia and professional risk maintain the status quo. Scientists challenging prevailing theories often face funding difficulties, career setbacks, and professional ostracism, creating bias toward incremental modification rather than revolutionary interpretation. But the evidence has always been there. Vertical canyon walls, flat floors, the disproportion between modern rivers and the canyons they supposedly carved, worldwide similarities, sedimentary layers showing rapid deposition, the lack of erosion between layers, enormous gravel deposits requiring extreme water velocities, walls that appear freshly carved, all point to catastrophic formation. Recent studies of dam break floods, glacial outbursts, and Paleo-lake megafloods confirm that catastrophic water flows can shape landscapes on scales previously thought impossible under uniformitarian assumptions. The Grand Canyon's Kaiba Plateau illustrates the dilemma. Conventional theory insists the Colorado River carved its way through the highest part of the plateau rather than flowing around it. Rivers don't flow uphill, they follow the path of least resistance. The standard explanation requires millions of years of precisely coordinated uplift and downcutting. The catastrophist perspective is far simpler. Immense volumes of water flowed across the landscape, carving everything in their path. Hanging tributary canyons, talus slopes that are mostly absent, water gaps cutting through mountains, and boulders that could only move under extreme velocities all reinforce the picture of recent catastrophic formation. What created these canyons was not millions of years of patient erosion by small rivers. It was floods of unimaginable magnitude water flows dwarfing the largest rivers on Earth, carving miles-deep canyons, depositing hundreds of feet of sediment, reshaping continents in years or decades. The canyons are uniform in structure because they were all created by the same process, likely within the same general time frame. The evidence has been etched into rock and sediment layers for anyone willing to see beyond the conventional narrative. Once you see it, you cannot unsee it. The canyons speak clearly. Catastrophism, not uniformitarianism, holds the key to understanding Earth's geology. It's time we started listening. Thank you for listening. Comment, like, and subscribe if you found this insightful or want to share your thoughts.